Everybody knows that you need gasoline to put in your car in order to make it run. But what we never think about is where that energy actually comes from. What happens with the gasoline inside the engine that makes it move? We're going to do an experiment here that you can do at home. All you need is milk, food coloring, dish soap, and a Q-tip. So what you want to do is you want to take the whole milk and you put it into your bowl, and then you put in the drops of your food coloring. Take your Q-tip, put a little dish soap on it, and then if we stick it in, watch what happens. I didn't move the Q-tip at all. I am adding no motion to this, and yet you can see that the milk is moving. The colors are flowing. How is this possible? It seems to violate the conservation of energy rule, that energy can neither be created nor destroyed, and it can only change form. So what do you think is causing the milk to move? All right, so what do we think caused the milk to move? So remember, seemingly without adding any type of energy, we got the milk to move. That means that the energy must have already existed within the milk for it to move, and we just had to make it, add something to it in order to get that energy to be released. So the milk is made up of atoms, and atoms can be as simple as hydrogen that has one proton and one neutron and one electron, all the way up until I think about 117 is how many elements we've discovered so far. So if you think of an atom, we'll think of a hydrogen atom in this case, consists of your nucleus here, which consists of one proton and one neutron, given an overall positive charge, and then there's an electron moving around here that has a negative charge. If opposite charges attract, then shouldn't the electron be attached to the proton in the nucleus? So since it's not, we know that there's some sort of energy keeping that electron in orbit around the nucleus. There are a couple of ways that you can unlock that energy associated with the matter. One way to do it is to get the electrons flowing from sort of a chemical reaction like in a battery. So there's a chemical reaction that if we were to connect these two leads would cause the electron to travel from one side to the other, and then we could use that electricity to power whatever device that we're using. Another way to release energy is through the breaking down of chemical bonds. In this case, we're going to break down the chemical bonds between carbon combined with the oxygen in the atmosphere to produce an exothermic reaction. I chose sawdust because I thought it would light easier. And so this is what happens in your car engine, but it happens at a lot faster rate. That produces an explosion that powers the pistons that drive your car. So we can think of matter not as something that's boring and sits still, but as a source of energy. And Einstein most famously said this with his famous equation, E equals mc squared, or energy is equal to mass times the speed of light squared. So the third way in which you can get energy from matter is through a nuclear reaction.